Welcome to Thermapan's structural insulated panel installation video. SIPs fulfill four critical aspects of the building envelope design: the structure, insulation, air barrier, and vapor barrier. In traditional construction, each of these materials must be installed separately, whereas for SIPs, they are all part of a single component. It's no surprise that there are considerable labor savings when building with SIPs. When it comes to structural strength, SIP walls outperform traditional construction by far. In a stud-framed wall, loads are typically distributed at 12, 16, or 24 inches on center. To understand why a SIP can support more weight than studs, let's take a look at its underlying structural properties. A panel shares the same characteristics as a steel I-column, with the EPS core acting as the web of the column and the OSB skins acting as the flanges. Now extend these structural characteristics along the entire width of a panel, and it's easy to see where a SIP gets its strength. By evenly distributing loads across its top surface, a single panel can actually support 3 to 7 times the loading of a conventional stick-framed wall. Thermapan manufactures SIPs with precise tolerances to ensure maximum productivity on the job site. The EPS core of each panel is recessed by 1.5 inches at the top, where a top plate will be inserted. The sides, where the panels connect, are also recessed by 1.5 inches. And likewise, the bottom is recessed by 1.5 inches to fit perfectly over top of the bottom plate. Building with SIPs just requires standard carpentry tools with 3 notable exceptions. A hot knife is commonly used to recess out EPS from panels cut on the job site. Expandable adhesive foam is used to secure SIP connections and establish a tight seal. And finally, a Prozzi beam cutter is a popular attachment to standard circular saws in order to cut through panels easily and accurately. All 3 items are available for purchase from Thermapan. Now that we've outlined some of the basics of SIP construction, let's get started on installation itself. As with stud framing, you need to set your bottom plate first. The key with SIPs is to lay the bottom plate with the 1/2 inch gap between the plate and the edge of the perimeter. Likewise, a 1/2 inch gap is needed between plates wherever a corner connection is planned. As we'll see shortly, these gaps allow panels to fit perfectly in place. When putting panels up, SIP installers always start with a corner, which gives them the necessary bracing and ensures that walls go up square and level. To prepare the first 6.5 inch R28 corner panel, we first connect an end plate and a connecting stud. Apply expandable adhesive foam, position the 2x6 studs, and secure the end plate to the panel's OSB with screws or nails at 8 inches on center on both sides. Position this initial corner panel, then apply foam to the bottom plate and raise the panel into place. Now foam the bottom plate and connecting stud to prepare for the second panel. Pivot the second panel on its bottom corner and position the other bottom corner along the connecting stud of the initial corner panel. The panel will now simply fall into place. Using a persuader block, the 2 panels can be nudged to create a tight connection, and when you've ensured that all is square and level, both panels are then nailed to the bottom plate and to each other. Note that for illustration purposes, we are only showing this task on the interior side, but on the job site, always make sure to nail on both the interior and exterior sides. With the corner in place, we now look at how to connect additional panels. For this, we use SIP splines, which are essentially 3-inch wide mini panels, in that they share the same insulative properties of standard panels. With standard 8 or 9 foot walls, it's best to secure the spline into the connecting panel before positioning the panel to the wall section. Foam the edge recess of the connecting panel, insert a spline and nail it into place on both sides. Then foam the edge recess of the receiving panel and the bottom plate, and pivot the new panel into place. Finally, nail the new panel to secure it. Let's watch these easy steps again with 2 more panels, keeping in mind that not only are we erecting the wall frame, but the wall insulation too. And when the entire wall section is in place, an effective vapor barrier and air barrier are achieved just by caulking the seams of the connecting panels along the interior side. The wall is all ready for drywall and siding, just like that. SIPs are extremely versatile and can be used with practically any building design. To see why, let's now look at how to go about constructing a gable wall. Panels are easy to cut using a Prozzi beam cutter, and then using a hot knife, simply hollow out the necessary 1.5-inch recess for a top plate along the cut side. There's our gable panel. Now, when installing gable panels, or for that matter any SIPs that are more than 9 feet tall, it's best to secure the spline to the receiving panel rather than to the connecting panel, as we saw previously with a standard wall installation. Splines are a maximum 9 feet, so we'll need to stack spline sections for walls higher than this. Here we see a 1-foot gap at the end of a 10-foot panel. This gap makes it easy to pivot the panel on its corner to connect it to the wall segment. Without the gap, the corner of the spline would potentially be crushed by the weight of the panel. When the panel is in place, we have easy access for connecting a small 1-foot spline piece. Using the same principle, we can connect the remaining gable panels. Watch how foam and nails are the essential steps that are completed with each and every panel. SIPs come in heights of 8, 9, 10, 12, 14, and 16 feet, accommodating nearly any wall or gable design. Let's take this opportunity to illustrate how this particular wall segment is finished. Recall that we've cut out a 1.5-inch recess along the top edge of our panels. This will allow for a top plate. We first spray in expandable foam and then insert and fasten the top plate to the SIP OSB on both sides. We then finish the wall segment with the 1 1/8 inch cap. Finally, we'll apply caulk along the interior seams of the panel, sealing the wall against air and moisture penetration. Builders are always curious about how windows and doors are framed with SIPs, so let's move on to a typical door opening. We start with 2 panels already in position, separated by the required opening width. Apply foam seal and insert the jack studs on both sides of the opening, and fasten them into place on both the interior and exterior sides. Next, we'll insert a header plate made up of 2 2x boards on the top of the jack studs and fasten it into place. Little jacks are fastened in pairs, and they are then installed into the panel recesses above the header plate, completing the connection where a header panel will sit. The header panel, which we've cut and grooved out a 3-inch recess at the bottom and 1.5-inch recesses at the top and along the sides, now slides nicely into place. When the full wall section is in place, a top plate and cap are installed, just as with a regular wall section. This panel header approach is used for loads that do not exceed the maximum allowable loading for a given opening, based on the thickness of the panel and the width of the dimensional lumber used. This information is readily available in Thermapan's installation manual. When the loading exceeds the allowable weight, we'll install a conventional header or beam, so let's back up a few steps and watch how this is carried out. With the jack studs in place as demonstrated earlier, we now position the header or beam on the jack studs and fasten it into place. Finally, we install the top plate and cap. Let's take a look now at another common building scenario, point loads. With SIP construction, point loads are handled very much the same as traditional construction, by adding a column of 3 or 4 studs for additional support strength. The stud column is installed in the SIP wall the same way as a regular spline, by applying expandable adhesive foam and fastening it to the OSB skins of the panel with nails or screws. Thermapan's installation manual provides guidelines to help with point load requirements. Now that we've covered the basics of SIP installation, let's examine some important workflow tips that help improve construction efficiency. We'll do this by illustrating how to go about installing a 9-foot high, 30-foot long, 6.5-inch thick wall section with one 4-foot by 5-foot window opening and a 6-foot wide patio door opening. Typical installation carpentry crews for SIPs consist of 3 to 4 people. The lead carpenter is always measuring and sizing, while the helpers are installing. With the bottom plate in place, the first step is to measure and mark off the position of all your components. First, mark the end stud. Now, mark 4 feet of panel wall followed by the jack studs for the 4-foot window opening. We also mark the lumber for the window sill panel. Now there is 10 feet of wall between the window and door opening, so we will mark the panel spline connections. This 10-foot wall section will be made up of 2 4-foot wide panels and a 2-foot wide panel. Where the 2-foot wide panel section ends, we will mark a jack stud for one side of the patio door opening, followed by a 6-foot opening, and then mark a jack stud for the other end of the opening. We will now account for the remaining 6 feet of end wall by marking a 2-foot spline connection from the jack stud, and finally marking the end stud. The second step is to prepare all the panels. Our takeoff for this section shows that we'll use 5 9-foot panels, 1 10-foot panel, and 3 9-foot splines. We'll cut one of the 9-foot panels lengthwise to create 2 2-foot wide sections and groove out a recess in the EPS with a hot knife. And we'll cut the 10-foot panel into 4 pieces, creating our windowsill, window header, and door header. The 4th piece can be used elsewhere on the house, so it won't go to waste. One great thing about building with SIPs is that there is little construction waste. Panel cutoffs are often reused for headers, sills, or smaller connecting segments. Now that our panel components are ready, it's time to install. With a corner panel already in place, we secure a 2x6 end stud and 2x6 corner stud to the first SIP, and then position it into place. When the corner assembly is tight, square, and level, it is fastened to the bottom plate, and the receiving panel is nailed to the corner plate of the first SIP. Leaving room for a 4-foot window opening, we position the next panel according to our pencil marks on the bottom plate, as we see here, and fasten it on both sides. We then put a spline on one side of the third panel and connect it to the second panel. According to the plan, one of the 2-foot wide panels we had previously cut goes next, to complete our 10-foot wall section, so we insert a spline and position it on the wall. We now have a 6-foot opening for the patio door, followed by 6 feet of wall section at the end of the wall. The 6-foot section is comprised of a 2-foot wide panel and a 4-foot wide panel splined together. We first install the 2-foot panel and fasten it to the bottom plate. For the final 4-foot SIP on this wall section, we place a spline on one side, which will connect to the 2-foot wide panel, and a 2x6 end stud board on the other side. Now that all our SIPs are up and in place, we turn our attention to the openings. For the window opening, the jack studs are installed first, followed by the double 2x6 header plate. Next, we add the little jacks and then we lower the header panel into place and fasten it. For the window sill panel assembly, 2x6 lumber is inserted and secured along the top and side recesses of the sill panel. Now the panel is inserted into place and is secured to the jack studs and bottom plate. For the patio door opening, This example assumes that the loads on the header will be within the maximum allowable loading, as specified in the Thermapan installation manual, so we will install a header panel rather than a beam. Just as with the window header we just saw, we start with the jack studs, a double 2x6 header plate, and the little jacks. Then we lower the panel header into place. Now that our wall is complete, it's time to install the 2x6 top plates and caps. First, we need to saw off a small section of the OSB at the top corner, because it is important to overlap the plates in the corner. When installing the top plates and caps along the length of the wall, it is also important to offset the top plate joints with the cap joints. All that is left to do is to caulk the interior seams of the panels. This ensures that a vapor barrier is achieved. There you have it. A 30-foot long wall section can be completed efficiently and in a fraction of time it takes for conventional framing and insulating. In conclusion, this video has demonstrated the basics of SIP construction and provided an understanding of how panels go easily together to build a solid structural frame. The Thermapan installation manual contains dozens of detailed drawings to help builders with all types of configurations. When you build with SIPs, you deliver quality and many benefits to the homeowner, from energy efficiency to living comfort. Thermapan is the better way to build.